Okay, so this is internal resistance in Kirchhoff's rules. So please take that out. And okay, so I have that out. Okay, so basically the internal resistance is a device's own resistance. And generally speaking for us, it'll be the resistance on a battery. So this entire battery here consists of the cell. All right, so that's called a battery cell. That provides the actual voltage. But because the battery itself has its own resistance, we have to consider that part of the battery. All right. So the EMF is a voltage or potential of just the battery cells. The terminal voltage is the actual voltage between the terminal of the battery. Okay. So the terminal voltage is the EMF delivered by the cells, which is just another term for voltage. It actually stands for the term electromotive force. Okay, and then this is the voltage drop at the internal resistor. It's actually pretty easy, right? So it says the drawing shows the resistance is connected in series with internal resistance. All right, so any resistors that we have out there are just in series with the battery resistance. Just the best way of thinking about the internal resistor is it's just another resistor, but it's connected to the battery and it's in series with the rest of the circuit. All right, it's just another resistor. So the example question is the battery has an EMF of 12 volts and an internal resistance of 0.01 ohms. What is the terminal voltage when the current I drawn from the battery is 10 amps? So here's what we would do. We know that V equals IR. Okay, we know that V equals IR. And the current they're telling us that's going through that internal resistance is how much? Are they telling us that?
10 amps.
Okay, we know we've got 10 amps there. So in that resistor, we've got a battery circuit. Thank you. A resistance of 0.010 ohms. Okay, so that gives me a voltage drop at just the internal resistance of the battery of 0.10 volts. Okay, so to find the terminal voltage, to find the terminal voltage we take the total EMF, which is 12 volts. Again, EMF is just another word for voltage. I subtract this value of the 0.10 volts, and the battery, because of its internal resistance, is actually producing 11.9 volts. So that's why in your batteries, in your car batteries, sometimes you'll find that it's not exactly 12 volts. It actually could be more or less because of the internal resistance. Okay, car batteries actually have a lot of internal resistance to them. Yeah.
So the terminal voltage is the actual voltage in the circuit, and then the EMF is what the voltage would be if the battery didn't have any resistance.
Exactly. Couldn't have said it any better. Okay, good job. All right. So Kirchhoff's rules. Okay, so this is these are the rules that we will. There's never been a Kirchhoff's law problem. There has been a version of it on the AP test, but you never know. So we'll cover the Kirchhoff's rule stuff. Okay. So the junction rule, basically, we know the junction rule. It says the currents going into a junction equal the currents coming out of the junction. We will hardly ever use a junction rule. So just the junction rule just goes like this. So if I've got a current, let's say I got two currents going into, let's say I got I1 here and I2. So we already know this. And I will get out another current. So this is a junction, I3. What can we say about I1, I2, and I3?
I1 plus I2 equals I3.
Good. I1 plus I2 equals I3. Okay, the more important of the two rules is actually the loop rule. The loop rule says around a closed circuit loop, the voltage drops equal the voltage rises. All right? So that is really, so on your multiple choice test, you need to know that the loop rule, this has come up on multiple choice test questions, The loop rule is a version of energy conservation. Energy conservation. So know that for multiple choice type questions. Okay. Now, so for the sample current, we want to find the current in this circuit. So we're going to follow these steps that are in this slide here. It says, choose an arbitrary starting point and direction for the current. All right. I'm just going to call this point right here A, and that's going to be my starting point. And I'm going to choose a direction like this for the current, I. So I have no idea what direction the current is actually going or what its value is. But I got to choose one because I just don't have any idea. So I'm going to choose that direction. It says if the current goes from positive to negative through the battery, then it is a voltage drop. If the current goes from negative to positive, then it is a rise. When the current goes through a resistor, it's a voltage drop. So what we have to do is we have to add up all the drops and add up all the rises and set them equal to each other. Okay? So let's look at the drops first. So over here, I'm going to list the drops. So at location A, I'm going to first come across this battery. All right? This is the positive end of the battery, and this is the negative end of the battery. So the 24 volts there, is that going to be a drop or a rise? Okay, that's going to be a 24 volt drop.
Wait, so the big end's always positive?
Yes. Okay. In any direction that I go through a resistor, it doesn't matter. The first part that I go through is always positive and negative, depending on how I'm listing them. Okay, so this 8 ohm resistor, is that going to be a voltage drop or voltage rise through that 8 ohm resistor? It's going to be a drop. It's always a drop for a resistor. So I'm going to call that, because I don't actually have the voltage, but I'm saying the current is I, the actual voltage drop will be I times 8 ohms. Okay, so that's the voltage drop through the 8 ohm resistor. So I keep following the current, and I get to the 6 volt battery. The 6 volt battery, is that a drop or a rise?
It's a rise.
It's a rise, because I'm going from the negative to the positive when my current gets to that point. Okay, so that I'm going to list as one of my rises. So that's a 6 volt rise. Now I'm going to go through this 12 ohm resistor. Is that going to be a drop or a rise?
Drop.
It's a drop, because anytime we go through the resistor again, it's always a drop. So that's a current I times 12 ohms. Okay. So what we then do is we set all the drops equal to all the rises. So we get 24 volts plus 8 ohm I plus 12 ohm times I. I don't know why I did that backwards. And I'm going to set that equal to 6 volts. Okay, so just taking the units out, I'll get 24 plus 8I plus 12I is equal to 6 volts. So my 8I and my 12I give me how much? Okay, that's 20I is equal to 6. So I'm going to subtract the 24 from both sides. So I get 20I is equal to negative 18. So my current is actually the value negative 0.19. Negative 0. Oops, that's not right. There's no 1 there, right? Let's erase that. Let's get rid of the 1 and the 9 there. So that's actually 0.09 amps. Okay, is it positive or negative? Okay, so what do you think? Yes.
If you had set the current in the other direction, would it be positive?
Exactly. So what we then do is we say the current is actually going. The actual current is actually going which way? Yeah, actual current is actually going clockwise. Okay, clockwise. Okay. All right, so that's an easy version of the junction rule. The two-loop version I'm not giving you just because they've never had that on the AP test, and I frankly think that would be really unfair because it would take a long time to do, because then you have to solve a simultaneous equation. The best way, or 3 simultaneous equations to solve that, and you'd have to put it into a matrix function to do it quickly into your calculator, right? So I just kind of made the decision that's probably not going to be on the AP test. All right. The two-loop version. This is just a one-loop version. So I do want to show you this, though. Okay. This is the same circuit. I want us to find the voltage drops at B, C, and D relative to point A. Okay. So we know the current is actually going in what direction? Okay. We actually know that the current is going in this direction, and we know its value. We know, the value of the current is 0.9 amps. So between B and C, okay, between A and B, what would my voltage drop be? If I go from location A to location B? How would I figure that out? What is my voltage drop?
49 times 12.
Good. So that would be 0.9 times 12 ohms. Okay. And that gives me a value of 10.8 volts. But it's a drop, so I actually have to label that what? I have to label that negative. It's a negative 10.8 volt drop. Okay. Then from A to C, okay, I have what's going on at the 6-volt battery. Is that in this direction clockwise? Is that going to be a drop or a rise? It's going to be a drop because it's going from the positive to the negative. So there I'm going to have negative 10.8 volts minus the 6 volts of that battery. So I'll get negative 16.8 volts. So this is actually the more important topic, knowing how to calculate voltage drops from one part of the circuit to another. Then going from location A to D, before I can solve for location D, I need to get what what value there? What do I need to get before I can solve for the drop from A to D?
Drop at the 8 ohm resistor.
Yeah, let's find the drop at the 8 ohm resistor. So the voltage drop at the 8 ohm resistor would be calculated how? Yeah, it'd be 0.9A times 8 ohms. And that's what, 72? 7.2, thank you. 7.2 volts of a drop. So I went from negative 10.8 minus the 6 volts, and this should come as no surprise. Subtracting 7.2 would give me what? What's that? It should give me 24. Okay, because once I get to here, I'm sorry, negative 24. Okay, because when I get from A to D, all I have left is a 24 volt rise, right? Because by the time I get back to A, the drop should be what? 0. Okay, so when I get from A to A, the drop should be 0.
Does that
Okay.
actually work?
What's that?
Picking up a battery, like the positive end of one battery to the positive end of another.
Oh, these are completely theoretical, right? So there's no reason to really set up a battery like that. I mean, there are some practical reasons to set them up in double loops and triple loops, but in a single loop like that, there's no practical reason to set it up that way. It's completely theoretical, right? Okay. So here's what I want you guys to do.